time, we'll talk a bit about the design, how to do big data analysis for threat intelligence, how I did it. I could share some lessons with you. So, as I mentioned, Cymon is right now an open tool that everyone can access. The idea was our SOC really needed a way to get threat intelligence about certain IP addresses, domains, to really figure out if something is bad. There's so many feeds out there, and the problem is, which one do you use, what's better, and that's what Cymon was modeled after, basically the requirements of our SOC, but it grew more than that. And threat intelligence sharing is the biggest thing right now, and this is our attempt to help the community. Really, if all of us shared our knowledge, whatever we know about attacks and other information related to that can help us prevent these attacks, it'll be a lot easier for us. So that's our crack at trying to get threat intelligence sharing out there. So essentially, Cymon, the idea is that you can go to Cymon, punch in an IP address or a domain or URL, and you'll get this type of information very quickly. You can tell right if an IP address is malicious. So, and as an example, this is probably very bad. As you can see, there's a lot of different types of reports on it. Companies like snort.org, Google, Fish Tank, and so on reported that there's a bunch of bad things on this IP address. So that's just a quick look. But all this data comes from a lot of different sources, and it contains information about malware, phishing attacks, botnets, and other kind of scanning activities and so on. So all of this gets aggregated in Cymon, and you have access to see all this information in a very easy way. Now, Cymon is technically a big data analysis tool. It ingests a lot of information every day, and on average, I would say there's about 15,000 unique IP addresses that get added to the database. So it's growing quite rapidly. So we have about 2.7 million IP addresses as of last night, and over 10 million events. An event is something happened on this IP, a phishing attack, or malware was detected, that kind of stuff. That's an event. So just to give you an idea of the type of how much information actually comes in, so this graph is a little bit outdated, but it's still pretty accurate. Now, this chart shows only the events themselves. So the blue line are the events that get ingested on a daily basis. So each dot is 1 day, and you can actually see a pattern forming. The lines below are actually IP addresses and domains. So events obviously are the biggest data set right here. So as I mentioned, there's about 200 different sources that Cymon goes out and ingests from. So I'm talking about stuff like VirusTotal. There's some websites that will put a list of recent DGA domains or other attacks. And all of these basically get aggregated. So Cymon would go out, either pull a feed, or we scrape a web page, or connect to an API to get this information. So there's different sources and different ways of retrieving this information. And the problem is, right, you have to have multiple tools to do that, and Cymon is basically the answer to that. To make it a lot easier, all we have to do is just add another source, and it's got its own unique way of handling the different data sources. So yeah, just a quick view, just a nice graph to show you the type of information we have. So we have a web interface and this is something that's not yet live. It's going to come out probably in the next week or two. So you guys are the first ones to actually see how it looks like. So let me show you a quick demo. So yeah, so this is that's the web page, as you can see, and that's what you'll get when you search for an IP address. So Cymon will show you whatever relevant URLs might be associated with this IP address, the domains. So Cymon doesn't really go out and does lookups necessarily. It'll do sometimes, but most of this information is collected passively. So we'll associate domains with IPs and URLs with domains and IPs based on the events that we're collecting. But the real useful part about Cymon is this timeline. So this AP, if we go to the bottom of the page, we can see that 5 months ago, a certain website reported about a phishing attack that was hosted on this domain. And if we go further up, we can see that there's more and more stuff going on. So 2 months ago, Google Safe Browsing reported malware. Then it was blacklisted by this specific DNSBL service. URL query recently, 6 days ago, was reported on probably malware. And you can actually click on the URLs and get more information to get the full context. But now, as a researcher or a SOC analyst, this is great information for you, because now you can tell, now this is definitely malicious AP. If we look back, we can definitely see there's been a long history of different attacks and different attempts to either compromise users or scan machines directly from that AP. So, yes, go ahead.
How far back will we go in regards to what data is tracked? How far back is the data?
That's a great question. So, Cymon started running officially, technically, 5 months ago. Back then, it only ingested maybe 20 to 50 different sources. So it goes back, since I started running it, but the plan is to have it keep running for a while. That way we'll get a nice historical database of everything that happened on an IP address. So, and it's great for multiple reasons, not just for research. If you need to know, if you get something on your thread board and you need to see if it's bad, yeah, that's great, but you know what, also for research. If you want to know which are the worst networks, which feed provider comes up with the lists the worst APs the soonest, the quickest. There's a lot of different analysis that you can do with all this database, and all of it is available for you guys. So, and I'll get to that. Yeah, so this is the newest interface we're working on, and we also just added comments. So the idea is really to create a community around the tool. So if we're saying it's bad, but maybe someone else is going to go in the comments and say, this is actually a good website that got compromised for a very long time. So that gives extra context to this information, very much like VirusTotal does it. And really, that's what I'm trying to model it after. Just have a community around it that helps enrich the data further. So I showed you an example. These are other bad IP addresses that you could also check out later. You all saw the globe visualization. This just pulls down everything that was reported in the last 24 hours. Same thing with the map. It's kind of fun to play with the map because you can definitely see the worst countries where these attacks come from. It gets quite obvious. So we also have an API interface that we're releasing. So just right now, the website is technically not released, but it's available for you guys. So you can definitely come and test it. It's technically in preview mode. So feedback, definitely welcome. And same goes for the API. The API is technically not official, but you can definitely access and use it. If you need higher rates, so we'll throttle your requests if you make too many requests. But if you need higher rates, then you can contact me and we can definitely arrange that for you. So yeah, so we're working on our documentations as well. That's how it looks like, but it's not complete. You can check it out if you want at docs.cymon.io, but some of the links are not going to work, like the API registration page. There's a link there, and that's not connected yet. And we also have a Twitter robot, which is like another API essentially. So you can actually tweet to CymonBot, ask it about an IP address, and it'll tell you if it's bad or not. So it's just a fun little, yeah, it's like more of a marketing stunt, but it actually works. Sometimes we have people that use it, so it's convenient. I was actually thinking of maybe down the road have the same Twitter robot basically have a list of all the malicious domains for the day, and every time it sees someone on the public timeline putting a link to it, it'll tweet back to them and everyone else who's looking at that tweet to warn them, don't go there. So yeah, that could be great for marketing, but also as a proactive way of warning people against phishing attacks using Twitter. Yeah, no, exactly. So that's what our marketing guys, we like the name because exactly you could play off of, yeah, exactly, Cymon says. Cymon, the name technically is supposed to mean cyber monitor, but it works just the same. So let me give you some excellent use cases. Some we use, some we have our clients playing with. For example, so we're generating a dynamic block list off of Cymon. This is something that you could use. I don't think it's ready yet. There's an API call to help you generate that and you'll have more control over the data. But in this example, every 15 minutes this list gets updated and it pulls down IP addresses that were associated in the last 24 hours with either malware reports or botnet related reports. That specific page only. But through the API call you can mix and match whatever type of reports you want. And that's great. You can feed that into your firewall, and it'll start blocking stuff. Now, keep in mind that the data that Cymon ingests is basically stuff that was reported by third-party sources. So sometimes it'll be funny things like, Google domains or Amazon, for example, because Amazon hosts so many things. So Dropbox, for example. Dropbox pops up a lot in the Cymon database. So you have to keep that in mind. But worst case, you blocked some access to a malicious ad network or to one of Dropbox web servers. So not the end of the world, but you can keep that in monitor mode if you wanted. So something recently that I've started playing with was machine learning, because Cymon can definitely get a lot more from the data set if we pass it through some machine learning. So the first crack I took at was actually try to figure out which domains were generated by an algorithm rather than human. So stuff that has random letters in it or something that obviously a human wouldn't come up with. So that's what the model I trained does, and it goes now. So Cymon actually uses that to check, but let me see if I can give you a quick example. So this is a list of a daily list of a bunch of DGA domains that gets updated every day. So this is a CryptoLocker domain. So did it copy it? There we go. So let's put in this domain and see what Cymon says. Yeah. Oh, yeah. Sorry. Slow internet. I'm tethered to my phone because obviously I'm not going to connect to the Wi-Fi here. After seeing one of the access point names was FBI vent. So yeah. So Cymon thinks that this is a malicious domain, and the probability score is very high. So it goes from 0 to 1, and that's bad. So that's obviously a domain, so yeah, Cymon was right. So yeah, so when new domains come in through different sources, Cymon will also send it to that, and that's an extra indicator. That's all going to go through in the end, so in the next month or so, I hope to release also threat scoring for each IP and domain. And the threat scoring would be basically the next level of machine learning. Basically, it's going to take a number of different data points, and basically, based on on the model I'm going to create, it's going to figure out what's going to be the threat score instead of using confidence and threat scores and stuff like that, which is how traditionally it's done these days. So something else you could do, for example, if you have some sort of an incident, someone broke to your website. Just an example. So this is just a script that I wrote very quickly yesterday. So you could definitely use Cymon, for example, to analyze your Apache logs and see how many malicious networks are actually connecting or probing your website. At this point, I don't care about really the URLs. I just want to see who the clients are, who's connecting to my website, and list them. So this example just shows 2 bad IP addresses that have a few sources. The script I wrote is in Python, and it would need to be modified if you have different log format, but just putting an idea out there. So Cymon, as I mentioned, this is the IP threat intelligence is one of the biggest pieces that Cymon does. But there's something else that we've integrated into Cymon. Right now, we use it only internally, but we're hoping to release it soon, and that's the monitoring aspect of Cymon. So there's a lot of value for our customers. They want to know when something that's related to their brand or their CTO or CEO, if any employee emails get leaked out, passwords relating to the organization in somehow, if anything comes up on stuff like Pastebin or Twitter, and even Bittorrent sites. So Cymon actually has the modules to go out and scrape those, and it does it every X minutes or X hours, depending on the service, and pulls this information, and it's got a set of filters that it's looking against, and if anything gets matched, then the customer gets alerted. So we're going to open it soon to the public, so you'd be able to register on Cymon website, create your own filters essentially, and get notified when something pops up on the network. So combining that with the IP threat intelligence gives you a really nice, robust tool, one place to go to unless you can afford more expensive tools. So, other capabilities yeah, go ahead. So it depends. Some websites have to be scraped. Other websites actually provide. So the question was, how does Cymon get this data from BitTorrent sites? Is it just metadata or everything? So I'll give an example. For Kickass torrents, for example, it gives you an hourly dump of all their torrents, everything that gets released. So in this case, it's very simple. I just grabbed up that file dump, unzip it, and basically run my regex through it. Yeah, go ahead. It depends what information is provided. So in some cases it'll be both. In some cases it'll be just the torrent file name, for example. And the reason different sites provide different interfaces to that. I don't want to, and these file dumps, for example, contain, tens of thousands, if not more, entries in them. And going out and starting crawling all of them seems pointless to me. It's really, I'm not interested in that at the moment. It's definitely an option, but I think in terms of development time and value that I'm going to get would probably be very low. So at the moment, yeah, I'm just trying to focus, I'm lazy, I'm a hacker, so I want to build things quickly and things that can help me the most. So I'm focusing on these at the moment, but it's a great question. So I just start mentioning that the tool also does DNS monitoring. So you can punch in your domain, it'll basically figure out all the records you have on that zone, and if anything changes, it'll send you an alert. So as you know, there's been incidents in the past. Something very recently just happened, with DNS hijacking. So at least you'll get notified before your customers tell you about it. And when I say passive IP monitoring and domain monitoring, is that so you can give me your IP addresses that belong to your company or domains, and if any of these get added to the threat database, the IP threats, then you'll get notified. So you don't obviously want to know if someone put malware on your domain or if someone's using your IP address to send phishing attacks. So you'll hopefully get that first from Cymon rather than one of your clients. So just a few examples. So this is a Pastebin alert that Cymon popped for one of our customers. And their email address and the password was listed for one of their employees. So, you see that, and obviously contact them and tell them, please change all your passwords now. This is what I call passive pen testing. So one of our clients' domains was found on this list, and this is a list of SQL injections. So if you read the top, what it says on that screenshot, 1,000 SQLI vulnerable sites. So just go nuts. And so this is something you want to probably get alerted on as fast as possible. And that's the type of stuff that comes up on Pastebin. Now, there are other tools to do Pastebin monitoring for you out there, but I wanted to have one tool and that can scale. And we'll get to the scalability part later. That's the dashboard, but that's the old version. The new one's going to look different, so we're working on that as well. So now, for the sake of full disclosure, I mentioned there's other tools out there, and I just wanted to mention them to you. Now, each tool does things a little differently. Some of them cost money, others you have to run by yourself. So Soultry Edge is something that's being used by the FS-ISAC, so a bunch of financial institutions. But this tool only takes data in taxi format. So it'll take, sticks format for events and so on, but you have to push it using specifically the taxi protocol. And I haven't seen a lot of, or any feeds out there that are free and that provide this type of format. So I can tell you our threat intelligence team at work, we run this, but we're not too happy with it. That's, coming from them. I didn't really play too much with Soultry Edge. Now, ThreadConnect, that's a company, and you can actually download their appliance, but you have to come up with all the feeds, find them, format them properly. You can have a hosted solution, but you get all of that for free through the Cymon website and API. In this case, it's a good tool, but Cymon's better. ThreadStack is actually something that's probably the closest thing to Cymon in terms of it goes to a bunch of open feeds out there on the internet. I think they have like 50 or 70 of them. But what they do with all this data, they basically generate bro rules. Bro is an IDS. You have their client, you run it on your firewall or server, and it'll just be it'll dynamically create rules for you. It's nice, but this is something you can easily use Cymon for. So just use the APIs. You create, a client, and it does it on your server. So there's really nothing to it. And finally, there's MostDef. Now, this is a platform developed by Mozilla, and it's more of like a SIM with Elasticsearch as the backend. And it's a nice tool. It works well. Mozilla uses it in production, and they recently integrated Cymon API. So when you come to here we go. So they're still working on it, obviously, but you definitely are going to get the data that's related to an IP address when it pops up on your board. So definitely something to look at if you need some sort of a SIM. Now here comes the fun part. Cymon is a cloud-enabled application. It's a bit more than an application, but the idea is that if I'm going to have 1,000 people or even 100,000 people signing up on Cymon, putting their domains, or if I'm going to add 1,000 different sources of data to ingest from, I want the tool to scale easily with minimum interaction on my part. And this is where Amazon Web Services comes into play, and using the right technologies. So I'm just going to show you what I'm using, and this is how we're doing our big data analysis. So at every given moment, Cymon is running at least one task, but usually there's like 5 or 20 running at the same time, and those scale up. So the foundations are essentially, everything is pretty much written in Python. Django is the framework I'm using mostly for the website, which is great because if your website ever needs to scale, they have all the little tools and utilities that you need when growing. For example, sometimes you need to start charting databases or having like a read replica, so you can easily create database routers on Django and route requests very easily and conveniently. Celery is the task manager. So the problem is all these processes take sometimes a long time to complete. And I need to have some sort of a queue to pull down the jobs and process them and save the results into a structured database format when I'm done. And that's where Celery comes in, and with an eventlet is just a non-blocking library to make networking calls. So if I need to make a lot of web requests to pull down pages or scrape something, eventlet comes in very useful. So I can run, instead maybe 5 threads, I can run 100 of them very quickly at the same time. And finally, Docker. Docker is a great tool. Whether if you use it for development or production, highly recommended. So some parts of Cymon actually run on Docker. The idea is to use microservices to make it easy to maintain and scale. So the biggest benefits with using this type of architecture is that we can scale really quickly. If we need to serve 1 million API requests, with a span of 5 minutes, no problem. I don't have to do anything. So it also makes it very highly available. I don't have to worry about you guys flooding the network. And the biggest thing, for me, I'm developing this technically on my own. And our sys group really are not supporting me on this. They have their own stuff to take care of all the mission critical stuff to the company. So it's great because Amazon gives me a database and they take care of backups and load balancing and failover and all that. I just have to tell them what kind of database I want and that's it. And the biggest advantage is cost saving. So if I ever had to build this inside our own data center, we'd have to do capacity planning and figure out the costs, and that's a big task. In this case, I only run the machines I need in order to serve or process the data that I got. If I have more data, then I just scale up. So this is a quick view of how the entire system looks like. There's 3 main components. So there's the data tier. And this one, essentially, so we're using Redis for caching stuff that needs to have, very quick turnarounds. Relational databases where define all the analyzed, the distilled items go into for consumption, and the API connects to that. And S3 to store stuff, that's really big, files, configuration, and so on. And now we have the workers themselves. This is where all the big processing happens. This is a separate environment, but the only thing that connects all of these is essentially the data tier. So as I mentioned, the workers also scale up and down, and I'll get to that in a minute. And finally, the web tier. So this is running on Amazon's Elastic Beanstalk. This is a great service. All I have to do is basically give them my application, and they worry about scaling it up and down. So really, the website is the easiest part. It's just, throw it on, and that's it, and forget about any other issues. So for the workers, it got really interesting developing it, but really the easiest way to explain it, when there's a new task and if there are no workers present, then a new one would be created by Amazon. They'll spin up a new virtual machine, which will connect to the S3 configuration bucket, download everything it needs to basically run all the startup scripts and specific configurations, and then start connecting to the central queue system, which stores all the jobs. It'll pull down the next 5 jobs in the line and start processing them. When that's done, the final results all get saved to the database, and then it's all ready for you for consumption. Yeah, and once that's done, it goes back again to the queue and pulls stuff down. So this is how we chose to do our big data analysis. So we could have used Hadoop with Pig and so on to really pull all these stuff, put it in a NoSQL database, and just do MapReduce on all of them and save them. But because of the nature of the data and the sources that are providing this information to me, it was really not practical. It would be, there's too many different formats to handle this. So in this case, a scalable worker environment works the best for us for these needs, just because of the different structure types. So I just want to share with you some stuff that's coming up very soon, stuff that we're working on. So as I mentioned, I don't know if I mentioned earlier, but probably maybe to other people I was talking to, we're working on a Google Chrome plugin. So the idea is basically to imitate ad block, but instead of blocking ads, I want to block malicious ad networks or websites that host phishing or malware and so on. So the idea is, it's extra protection for you. And ideally down the road, you should be able soon to select what kind of block lists do you want. Do you want to only block sites that have malware on them, phishing attacks, botnets, that kind of stuff? You'll have a way to control the type of data that comes in. And the plugin would cache, so every day it'll basically pull the last 24 hours to 1 week worth of IPs or domains that were reported as bad locally to the browser. That way it's very quick when you make new requests. So whether it's a website or an iframe on a website that goes to a bad site, that's going to get blocked by the plugin. So it's a work in progress, but it should be a lot of fun. And as I mentioned, Cymon is still in preview mode, so there's a lot of other pieces missing. And if anyone wants to contribute, that would be amazing. So just some ideas of what you can do with the APIs. A Firefox plugin would be amazing. We have a Python library for that we wrote for Cymon, so you can just, it makes it easier to interact with the APIs. But if you want to write one for Ruby or Node or something, please, I invite you. Let's build it up. Firewall plugins, proxy plugins, like if you have a corporate proxy, that'd be amazing if you could automatically just strip everything, or at least, at the very least, warn you when people go to sites that were reported as malicious. IDS plugins are pretty much the same. And Maltego transforms is another example. So it'd be really awesome if you can, punch an IP address in Maltego and then pivot into a domain using Cymon APIs. So that could be of a lot of value for you guys or other researchers if you're going after botnets or you're doing research. It'll be very useful. So someone mentioned that to me, and I just stole his idea and added that like the last minute here. Yeah, so that pretty much brings my talk to conclusion. And I'll be happy to take some questions if you guys have any. So remember, I got some lockpicks. I'm not kidding. So let's hear it. Yeah, go ahead. So there's a few ways you can go about detecting domain-generated algorithms, malware domains. One way is to do some sort of, randomness analysis, that kind of stuff, entropy. But the great thing about machine learning is that you don't have to figure this thing out. If you have a big enough data set, the computer will figure it out. Because machine learning is really modeled after the way the human brain works. So if you have enough samples, that's how you learn too, right? If you see enough things, that's how you learn. That's how computer vision works as well. But that's deep learning. That's even the next step. So machine learning, just give it enough data set, and it'll find the patterns in the code. So the way I started, I had a big list of known malware domains, and then I went to the Alexa top 1 million IP domains, and then other sources. And then I put it all together in one big list, randomized it, and pushed it through, and basically trained a computer model. And now once I had that, I just played around with the settings, made sure that the prediction accuracy is good enough for me, which was actually about 97%, which is excellent. And that's that. So really there was no algorithm or anything like that. It's basically, I asked the computer to figure it out on its own. And that's where machine learning is really great. So after you. So go ahead. Yes, and yeah, it's a great point. And I'm always struggling with the idea whether Cymon should be active or passive. Should it just collect data and do the analysis, and or should it also start poking stuff? So at the moment, everything's passive. I'm just collecting data and doing all the correlation and relationships. The problem with going active is that you might be knocking on someone's door who doesn't want public visitors. So that's the main reason I'm not doing any active scans. So you mean zone files from a DNS server to do like a zone transfer? So right now, yeah, I'm not pulling any DNS-related information. Cymon might do PTR lookups if needed, but that's a great point. It's something that I might look into because. So previously, in the previous version of Cymon, I actually had the capability of monitoring who is information for domains and IP addresses. If anything changed, that would create an alert. And I removed that because I had to flip the model of how I was doing and processing things. And it's really provided very little value for the amount of work that Cymon had to do. So for the sake of keeping costs low and I didn't see a lot of value, I turned it off, but it's something that I might look into again. So zone transfers or doing bulk whois lookups, that kind of stuff. But great stuff. So you'll get the lockpick as well. Go ahead.
Following up on the first question, would you be willing to talk a little bit about your machine learning? You said you fed a bunch of things to a computer and you can actually say magic that.
It's almost like that. Look, no. Yeah, and it's great, and it's really easily available these days. You can, just run it on Microsoft, Azure, or Amazon. But I'm not gonna lie, it took me a while. There was a lot of trial and error. I had to create a few models before I was happy with the results. Finding, the data points that you want to collect, and then there was a lot of correlations doing, a lot of Python scripts just to build the initial data set. So I think the biggest issue or the biggest hurdle to overcome when it comes to machine learning is creating the initial data set. It has to be very good. So you can have, there's also two approaches. There's managed or supervised learning, where you basically tell the computer, here's a bad example, here's a good example. And when it's got enough of it, it'll create a pattern. Another way is unsupervised learning, where you basically just push a large data set, but you don't know what's what. And the computer by itself is going to start finding patterns in the data. So this was managed, supervised learning, because I had a list of bad stuff and good stuff, which also created a higher accuracy model. And it's great. And come talk to me later if you have more questions about machine learning. Yeah, go ahead. At the moment, no. And the reason is because most of the sources I'm ingesting don't provide this data, most of them. And I would if, the majority would have provided this packet capture. Like, for example, Barracuda Networks has a website called something Glass, Threat Glass, yeah, where, they go and you punch in the URL and they'll run it, emulate it, and give it a packet capture, and then they'll tell you if they think it's bad or not. It's a nice website, but you can only go so far. It's great for but anyways, your point is that's one of the only sites that I know that actually gives you a packet capture back. Almost every source doesn't, and that's unfortunate. But the same thing with malware samples. I'm not collecting them, but some sources I will list either the hash or the URL for the binary or the name of the binary, depending on what the source provides. So some sources will just give me an IP address and a timestamp. Others will give me, virus total detection score, hashes, binary, everything. So the system really has to be very flexible to be able to support all of these data types. And then you'll be next. Yeah, go ahead.
Yeah, so when you talk about how does the algorithm determine if it's generated website, really kind of interested to see who registered that website, pull all the other websites that are registered, and say, all right, we've got a pattern validated in your algorithm, but also that I can say, oh, well, I've got a whole other list that I'm likely going to want to block because their same registering has done all those.
Definitely, and you're right. That's why whois information goes into my computer learning model, the machine learning model that I'm trying to use for threat scoring. So that's going to be one of the data points that go in there. I'm not listing it. Well, so when you go and search an IP or a domain, you'll see the whois information related to a domain, but I'm not doing anything with it right now. But it will go into the threat scoring mechanism. it'll be interesting to find out. But one of the biggest issues I'm going to have to overcome would be how to do whois lookups in bulk, because right now it's got like 2.7 million IP addresses and a bunch of other domains. So just but it's fun challenges, but it's challenges nonetheless. So right now I'm just doing it very quickly on Python scripts on my hand, usually just to build the models. 1 second, guys. So yeah, go ahead. Exactly. Like retire stuff? I get that question a lot, and no, it's a great question because it shows that you really understand on the way these block lists work. And so the answer is kind of mixed. First of all, no, I'm not retiring any information. Everything is going to stay in the database for research purposes. It's going to be really interesting to see what happened 2 years ago in an IP address and what's happening on it today. But when you're doing these lookups, if you want to generate your own blacklist, then I would recommend limiting the lookup history to like 2 weeks, something between 3 days to 2 weeks. So that way, that's recent stuff, and not something that happened a year ago, and only one blip came up on the screen. Yeah. Yeah, you'll also get a lockpick set. But yeah, so let me think. Sorry, can you repeat that? I didn't catch it. So yeah, because I'm looking into doing threat scoring now, please show me the number 9 after the 10. So because I'm doing, I started looking into the threat scoring, and it's going to be a big thing, because if you're looking up an IP, you want to know how bad is it. And one of the parameters you want to put in is probably confidence. So I started looking into that, but right now I'm not really pursuing this because I want to try the machine learning approach. I want to see if the computer can actually start recognizing patterns based on a specific set of data points. But definitely there's sources that sometimes, they send me like 127.0.0.1 as an IP address. So it's like obviously bad. You don't want it there. And the database with the API right now, you might get it. It really depends on the sources. So it's up to you right now to really remove it. And a confidence in a source would probably help alleviate this, but I'm not doing this at the moment. Just because there's so many sources, and now how can you start figuring out, what's reliable, what's not? Like, for example, PhishTank. It's a service that gives you a bunch of phishing domains and IP addresses, So I'm ingesting that, but if some phishing guy, decides that, he got caught, that's it, the site is not doing so well, so he'll change the domain to point to 8.8.8.8, right? Google's DNS server, or like 127.0.0.1. So when they do their own PTR lookups and save it to the database, they get this weird values. So that's the problem. You could have a very highly reliable source, but the way they ingest the data, or if they even bother doing some sort of extra validation, that's maybe the one of the issues with the data set. But because this is for research purposes, then I expect you to recognize it and prepare for it. So there's definitely a plan for the future. So, some monetization on Cymon. So maybe we'll provide like a filtered feed that was validated by the company. And we know you're not going to have any Dropbox related domains or Google IPs or Amazon stuff. But as a research tool or as a threat intelligence tool, I think it's more than enough, because your analyst will be able to tell immediately if it's bad or not. The IP information page shows you the whois info, and if you see Amazon, then you should skip it. It's sort of like a smarts test for analysts. But yeah, someone else had a question? Someone else? Anyone? Anyone? The guy in the back, yes. Sorry, can you speak up? Yeah. No, I don't think Cymon were able to predict, just because machine learning is not supposed to do that, to predict what's going to be the next set. You really have to look into the algorithm that they're using. So yeah, there's companies that, they'll take these malware strains and they'll figure out, how they generate their domains. So usually the seed component is either a timestamp or something else that the author also knows. And so I showed you earlier today actually a list of DGA domains, of malware domains. That list was generated this way, basically by figuring out the algorithm, and they just generated all the domains that the malware would generate for today. But, yeah. Yeah, exactly. I mean, yeah, I wish machine learning would be able to do that. Yeah, maybe 10 years from now. Yeah. Well, you'll definitely see the source for an event. So it'll be up to you to filter it out. Yeah. Really, the API is supposed to be super fast. So I'm just going to give you the basic functions that, make the API as fast as possible. And you need to do the secondary processing if you need to remove stuff. So that's a great question. You'll get a lockpick. I'm working on a feedback loop. So the idea is if we want to keep improving the machine learning model, then you need to keep providing feedback. So there's going to be false positives or false negatives. So the website interface will have, hopefully soon, an upvoting feature like Firestein has. So once that, someone comes up and votes, that will go into the feedback loop. The API should also have that included as well. So yeah, if users would participate and send feedback to Cymon, then I can definitely see improvement overall, and it'll just become more and more accurate. Yeah, and that's where ideally things should go. Yeah, Derek. Oh, okay, get it. Yeah, we have the ability to do private feeds. So if you're a premium customer, and for example, you want to ingest emerging threads and FS-ISAC feeds that are members only, right? You have to pay for it. But you don't want to start pulling multiple sources and you still want Cymon, then if you use the authenticated API, you'll be able to get the stuff that normal people can't see. So, I mean, obviously for licensing issues, I can only give you the stuff that was reported out there on the internet. That's accessible to everyone, but if it's a private feed, then. So yeah, the answer is yes. Anyone else? All right, so come claim your lockpicks, those that I told you that you get one. Thanks, everyone.